Good morning, students. Welcome back to science class on the chapter electricity. In the previous class, we discussed so many problems related to resistivity and resistors. Okay. Today we shall start. We shall study the resistance of a system of resistors. You know, suppose if you open, for example, say TV or computer or radio or some electrical gadgets. See, when you open those electric gadgets, you can see there are so many resistors they have connected. Okay, I think we have seen right this kind of resistor. Okay. Like this. Okay, so here just three lines like this, one line. Okay, resistors, because see here, nowadays the technology is becoming very smart, right? For example, if you take this mobile, so in this mobile you can see you can see what's going on around the world, right? Within a few minutes. Okay, why? Because see here, in these circuits we are using very small equipments, correct? See here, we have to send power for all those devices. So at that time, sometimes if the in those circuits, sometimes we have to avoid some kind of excess voltage. So to avoid excess voltage, so here we have to use these resistors. We can avoid, or we can reduce the excess voltage one using transformers. Okay, see in this kind of in this kind of devices we can't use transformers. Okay, why? Because the size of the transformer is a little bit big. Okay, so at that time we use this kind of resistors. Okay, in all the electricals we use these resistors for plenty of applications. Okay, and here we use these resistors in two ways. Okay, in two ways. So one, will connect, or we use these resistors, one in a series, or another one in parallel. Okay, so first we shall study what resistors in series. Okay. Yes, many students are online. Yes, good morning. So now no need to say good morning. Okay, just to concentrate. Okay, now no need to say good morning. If I ask question, then only put the answer to that question. Okay, so first we'll study resistors in series. Resistors in series. Okay, resistors in series. Now consider I have three resistors. Okay, so right, this is the symbol of resistor. This is the symbol of resistor. Now consider you have three resistors. Okay, so I will call this as R1, this is R2, and this is R3. Okay, so now if you connect these three resistors, means, see, if you connect one end of this resistor to one end of this resistor, and if you connect this end of this resistor to this end, then we can say that these three resistors are in parallel, which means if you connect the resistor end to end, okay, if you connect the end of the resistors, then we can say that those resistors are in series. See here, for example, now I will connect those resistors like this. Okay, see here I have joined the ends of the resistors. Clear? Here I have joined ends of the resistors. Correct? So now here we can say that these three resistors are in These three resistors are in series. Okay. Suppose if you had one more resistor here like this, so then we can't say these resistors are in series. Now this is now resistors. Now these resistors are not in series. Okay. If you want to say the resistors are in series, then you should connect the end to end of the resistors. Here you have to join only two ends. Here I have joined two ends. One this end and this end. Okay. So here we have to join only two ends. Then only we can say that these resistors are in series. If you had one more resistor over here like this, now we can't say these resistors are in series. Okay. If you want to say the resistors are in series, then you have to connect only two ends. You have to connect only two ends. So then only we can say that the resistors are in series. Now see here, you can draw this diagram. Only to draw like this only. Then you can draw this like this also. See here. Here. Now here also we can say that these R1, R2, and R3. So now we can say that these three resistors are also in series. Why? Because see, I have connected end to end. Okay, only two resistors I have connected two ends of the two resistors. Clear? So there is no other extra resistor right here. I have not connected any other extra resistor here. Okay, so just I have connected two ends. So then we can say that these three resistors are in series. So clear right? What is series? Okay, when you connect the ends of the resistors like this and like this, so then we can say that these resistors are in series. See, no need to now it is just like a straight line, and it is just like one square or rectangle, or you can draw in a circle in circle shape also. For example, say so now I can say these three resistors are in series. Clear? Suppose if you add one extra resistor here, then we want for these three resistors are in series. If you want to say resistors are in series, then you have to connect only two ends of the resistors. Only two ends of the resistors. Okay. So now we can say these three resistors are in series. So clear at series? Okay. Yes. Now we will study how the current and voltage. This is very important. Okay, so one problem definitely they will ask. They will ask either in resistors in series or resistors in parallel. Okay, see here, consider three resistors connected in series. Okay, okay, see here, so now these three resistors are in series. See here. See now the resistors are connected in series. Okay, in series, see here, in series, voltage, you are passing voltage, right? Electrons, they move from negative side to positive side. Okay, while flowing, they will face some kind of opposition here at R3, R2, and R1. Why? Because these are resistors. Resistors means what? See, what is the function of the resistors? They will oppose the flow of electrons, correct? It is the flow of opposition of electric current of electrons. Okay, now see here the if you connect voltmeter here, if you connect voltmeter across R3, here you will get 1 voltage. Suppose if you connect this voltmeter here to calculate the voltage across this resistor, so here also you will get different voltage. Okay, if you connect here also you will get different voltage. Okay, so clear, you know, right? So always we will connect see, we will connect the ammeter in series and we will connect the voltmeter in parallel. Why? Because here we should calculate the voltage between 2 points. So that's why we should connect this voltmeter in parallel. And then see, it is the rate of flow of electrons, right? The current means, so that's why we should connect the ammeter in series. Okay, now see here, in series circuit, voltage across the individual resistors are different. Okay, the voltage across individual resistors is different. Okay, if you connect voltmeter here you will get a different value. When you connect here also you will get a different value. When you connect here also you will get a different value. Okay, here the voltage across the individual resistors, so that is different. Okay, so here I will call this as V1, V2, and this is V3. Okay, but here current, okay, see, current across individual resistors, if you connect the voltmeter here or here or here or here or here or here, you will get the same current. Okay, so here in a series circuit, current is constant but voltage is different. Okay, in a series circuit, current I is constant, voltage is different. Voltage is different. Okay, so here in series circuit, current is constant and voltage across the resistors, that is different. Now see here you will get one value, so here also you will get one value, here also we will get one value, here also you will get one value. If you add these three values, okay, then you will get the same value. Okay, so that's why in a series circuit, voltage is equal to the sum of the voltages across the individual resistors, that is V is equals to V1 plus V2 plus V3. So clear? V is equals to V1 plus V2 plus V3. Okay, see, when you see, if you add the values of these values, okay, these voltages, then you will get the original voltage. So clear, right? So now here the resistors are in series. Here in series circuit, current is constant, voltage is different. Okay, but then current is constant, voltage is different. Okay, when you add the values of these three individual resistors, values of the voltage of the individual resistors, then you will get V. Okay, so that's why V is equals to V1 plus V2 plus V3. So clear, right? Here the resistors are in series. Okay, so that's why here current is constant, voltage is different. Now suppose I will ask how to calculate the voltage across here. I will give current across, see, current here across this resistor, current remains the same in a series circuit. Suppose, see, here you will get a 2 ampere, then if you connect voltmeter here also you will get a 2 ampere, here also you will get a 2 ampere, here also you will get 2 ampere. Okay, here also you will get 2 ampere. Now see here, how to calculate the voltage here. So in this, here also we use this relation only. Very important relation, that is Ohm's law. Voltage is equals to current into resistance. Okay, here if you want to calculate the voltage here, then here See, in this resistor, for this resistor, at our individual resistor, you have to use this one. V1 equal to I into R1. I is constant, right? I is constant here and here, so that's why we should take I current as I, not I1. If you take I1 here and I2 here and I3, then which what is the meaning? Then the current is also different. Okay, but in series circuit, current is constant, right? So that's why we should take current as I. Okay, next, if you want to calculate voltage across this resistor, there also you have to take V2 is equals to I into R2. Here you have to take V3 is equals to I into R3. Okay. Now suppose I will ask for overall circuit. I will ask calculate the voltage here. For overall circuit, you have to use this one. V is equals to I into R. See this formula for the entire circuit and this formula V1, V2, V3 for individual resistors. Okay, so in when the resistors are in series, here current is constant and voltage is different. Okay, now we can see here. Now here the resistors are in series. Then next move to resistors in parallel. So it is just reverse of this one. In parallel, current is different and voltage is constant. Why? We'll see. So clear, right, this one? Okay, so here yes, here you asked sir, if we have three resistors means here we have to draw three cells. No sir, but you drawn only one cell. Okay, see here, no need to draw one or two. Okay, sometimes you can use a one cell or two cell, whatever it is. Okay, that depends on how they will ask in a problem. No need to say one cell. Or, see, you can draw like this also. This is also correct. Okay, see. Sometimes they will use a 12 volt cell. Sometimes they will use 1.5 volt cell. Okay, you have no need to draw three cells for these three resistors. Okay, you can draw one or two also. This is the correct. Okay, you can draw one cell. No problem. Okay, sometimes you can draw like this also. Like this also. No problem. This is also correct. And this is also correct. Okay, no need to draw a cell for individual for all the resistors. Okay. Now next move to resistors in parallel. Resistors in parallel. Okay. Yes. Now here also consider three resistors. See here. Yes. See here. Now here, see, just observe here. Now I have connected all the ends of the resistors at one point. All the ends of the resistors at one point. Correct? Which means, see here, if you join, see now we can say that these two resistors are in series. Why? Because here just are connected only two ends. If you add one more end, if you add one more end like this, then we can say that these resistors are in parallel. Okay, so now here we can say that these resistors in parallel. Okay, so now here we can say that these three resistors are in parallel. Okay, just observe here. At this point also, here I have connected three ends. Okay, here I have connected three ends. So that's why we can say that these three resistors are in parallel. See, at one point, if you add more than three resistors, or if you join more than three resistors, then we can say that those resistors are in parallel. So clear, right? So when do you see the resistors in parallel? Okay, when you connect more than when you join more than three resistors, or when you add ends of the three resistors at one point, then we can say that the resistors are in parallel. Okay, so you can draw this diagram like this also. See here. Okay, see, now we can say that these resistors are in parallel. Okay, or see here. Now listen here. Now we can say that these two resistors are in series. These two resistors are in series. This combination, this entire combination, and this one, both are in parallel. See, remember, see here, listen carefully. Now these two resistors are in series. See, these two resistors with respect to this one, okay, both are in parallel. But these two are in resistor. These two resistors are in series. Combination of these two resistors and this resistor, both are in parallel. Okay. Now, see here, what about current and voltage? See here. Now here, see the current, the direction of current flow positive negative, right? So here current it flows I, but here now here three branches are there. Okay, so what happens here? Current it divides. Okay, here I divides into I1, I2, I2, and I3. I1, I2, and I3. So once again you come, once again you will get I here. Okay, so in parallel current is different. In parallel current is different and voltage is constant. Voltage is constant. See here, voltage across here and voltage across here, you'll get the same voltage. Okay, or voltage across here, if you connect voltmeter here for the entire circuit, okay, for these three resistors, then you will get the same voltage. Okay, in parallel, and the resistors are in parallel. Here current is different, voltage is constant. Okay, suppose here also if you want to calculate the current across this resistor, here we use V is equals to I1 into R1. Okay, across this resistor we use V equal to I2 into R2, V equal to I3 into R3. So clear? If you want to calculate I1, just write I1 is equals to V divided by R1. If you want to calculate I2, I2 is equals to V divided by R2. If you want to calculate I3, V by R3. Okay? See here I have taken VV only. I have not taken V1, V2, V3 like that. Why? Because here voltage is same in parallel circuit. When the resistors are in parallel, then voltage is same. Here current is different. Why? Here the current which divides, because see, which divides into branch currents. See, now we will call this is one branch, this is one branch, and this is one branch. Here current which divides, okay, divides into I1, I2, I3. So clear? See here, suppose here you are passing say 4 ampere. Here this 4 ampere divides into three branches. Okay, we don't know, maybe here one, and here 2, or maybe say here 0.5, here 0.5, and maybe here 3 ampere. That depends on the values of the resistors. Okay, no need to divide equal. Suppose you have say 6 ampere. Okay, see, we can't say here current across this is 2 ampere, 2 ampere, or 2 ampere like this. Okay, no need to divide exactly, but it divides maybe like this. Here 1 ampere, and here also 1 ampere, maybe here 4 ampere, or we can say that here 1 ampere, here 2 ampere, maybe here 3 ampere, like that. No need to divide exactly. Okay, but the current divides here. Suppose here if you connect the ammeter here, just imagine you will get what 6 ampere here. When you connect here also you will get 6 ampere. But suppose if you connect ammeter here, then you will get a different current here. Okay, you will pass 6 ampere. See, the current here 6 ampere. At the output means at the here, and this point also you will get the 6 ampere. But here you will get a different. Why? Because that current divides. Okay. See, here the current divides, and once again it will join here, so you will get the same answer. Okay, when the resistors are in parallel, current is different, voltage is constant. Now, to calculate the voltage across the entire circuit, for this one we use this formula. So V is equals to I into R. Okay, so here also we can say that current in the circuit, the total current in the circuit, that is I is equals to is the sum of the current across the individual resistors. That is I is equals to I1 plus I2 plus I3. If you add these values, these three currents, you will get the total current in the circuit. You will get the total current in the circuit. Okay, so clear, right? Next one, see here now, to calculate, suppose see, to calculate total current in the circuit, we use this formula I equal to I1 plus I2 plus I3. Clear? But I will ask, calculate the total resistance in the circuit. See, total resistance or equivalent resistance means, okay, I will ask, calculate the total resistance in the circuit. Now these three resistors are the circuit, right? If you want to calculate the total resistance means you have to make these three resistors as one resistors. Okay, you have to make these three resistors as one resistors. Okay, yes, see here. Now if you want to calculate total resistance in the circuit, then we have to use this formula, that is 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, see this formula, we use this formula to calculate the total resistance in the circuit. You can't see here, you can't add like this R1 plus R2 plus R3. Okay, this is wrong. Clear? If you want to calculate the total resistance in the circuit or equivalent resistance, then you have to calculate like this. You have to use this formula, that is 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3, and so on. If you have 4, then it is 1 by 4. If you have 5, that is 1 by 5. Okay. So now we use this formula. Why we we use this formula. So here we use this formula to calculate the total resistance. To calculate the total resistance in the circuit or equivalent resistance. Means, see here you have to simplify these resistors. Means you have to see your work is to make these three resistors as one resistor. Okay, if you calculate that, then finally you will get this entire circuit as like this. You have to simplify, means you have to make these three resistors as one resistors. You can't make directly. If you want to make these resistors as one resistor, then you have to use this formula. Clear? Okay. Now next, suppose, sorry, I forgot to say how to calculate total resistance in to calculate total resistance when the resistors are in series. Okay, see here we use this formula to calculate the total resistance in the circuit when the resistors are in parallel. Suppose when the resistors are in series, when the resistors are in series, say, okay, now these resistors are in series, right? So here, if you want to calculate total resistance in the circuit, here we use this formula. That is R is equals to R1 plus R2 plus R3. Okay, R1 is equals to, or we can define that when the resistors are in series, the total resistance in the circuit, which is equal to the sum of the individual resistors. It is the sum of the individual resistors. But in parallel, so total resistance in the series circuit, so it is the reciprocal of the resistance in the circuit, which is equal to the sum of the reciprocals of the individual resistors. So that is in parallel and this is in series. When the resistors are in series, we use this formula to calculate total resistance in the circuit. And just observe here this one. Here we use this formula to calculate the total resistance in the circuit when the resistors are in parallel, and we use this formula when the resistors are in series. Okay. Now see here. See, you are solving or you are calculating total resistance means what? Here also you are making these three resistors as one resistor. Okay. Now see here. See, now these two resistors are in series. Okay, I'll ask you calculate the total resistance, which means what? So here I will call this R1 and this is R2. Total resistance, we know the formula, that is R is equals to R1 plus R2. See, first of now these two resistors are in series, right? So when you add R1 R2, you will get R, which means at last you will make these two resistors as one resistor. Suppose say this is 2 ohm and say this is 4 ohm. Just add. So R is equals to 2 ohm plus 4 ohm. That is total 6 is R is equals to 6 ohm. Correct? So now it will become 6 ohm. Instead of using 2 ohm and 4 ohm resistors like this, if you use 6 ohm, both are same. Now these two resistors are same. Here you are using 2 ohm, 4 ohm. Instead of these 2 ohm and 4 ohm, if you use 6 ohm, you will get the same answer. Correct? Here solving means you are solving the circuit means you are making the resistors as one. Suppose if you have 3 resistors, okay, say this is 3 ohm, then you get total 2 plus 4, 6, 6 plus 3, 9. So instead of if you use 9 ohm, you can use like this also. 9 ohm also. Means just here you are making these two resistors into one resistor. Okay. Now, See here. Now I'll ask calculate the equivalent resistance. Means see here. For example, say this is 2 ohm, this is 4 ohm, and this is 8 ohm. Okay. So now I will ask to calculate the total resistance in the circuit. You know the formula, that is 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R3. Clear? So now substitute the values. So R1 value is 2 ohm plus R2 4 ohm plus R3 is 8 ohm. So what is the LCM? That is LCM is 8, right? So here 4 plus 2 plus 1. So 1 by R equal to. So just add, I'll write here R equal to 5 by 8. Then see we need R, right? So now just take the reciprocal, that is R is equals to 8 by 5. So what is 8 by 5? 8 by 5 is 1.6. 1.6 ohm. Okay, so now we can redraw this circuit as here. 1.6 ohm. Okay, instead of using 3 resistors like this, 2 ohm, 4 ohm, 8 ohm, you can use only 1 resistor like this. Okay, now total resistance, here you have used 2 ohm, 4 ohm, 8 ohm, but the total resistance in this circuit is 1.6 ohm. See, remember here what, when you connect resistors in series in parallel, when you connect resistors in parallel, then the total resistance in the circuit which decreases. But when you connect resistors in a series, at that time the resistance increases. When you connect resistors in parallel, then resistance decreases. When you connect oh, sorry, here 4 plus 2 plus 1, 7, right? Sorry. Okay, this is 8 by 7. So what is the answer? 8 by 7? Yes, sir. 8 by 7, that is 1.14 ohm. Okay. Yes, so Sri Shailamai Nandini Power. Okay, you have said the answer right, correct, exactly right. Okay. Yes. So now here, so instead of this, if you use 1.14 of resistor. So clear, right? Here solving the or calculating total resistance means what? Here you are making these resistors into one resistor. So now here, see here we have did what? We have made 3 resistors into one resistor. So clear? So this means, see, in next class we are going to solve so many problems related to parallel and series. Suppose here you have circuit like this. I call this as R4. Now tell me whether this is a parallel circuit or series circuit. Just put in a comment box. See here, parallel. No, we can't. See here. Now these 3 resistors are in parallel. Okay. See, if you solve these 3 resistors, it will become one, right? We can redraw this circuit as, see here. We can draw this circuit as like this. See here we have solved, right? We got answer 1.14, right? So now value of this resistor is 1.14 ohm. Okay. See here solving resistor means what? You are making these 3 resistors as one resistor. When you solve here, you will get only one resistor, right? That is like this one. Now what is the value of this value of this resistor is 4 ohm. So now this is R4 equal to 4 ohm. Now observe here, these two are in series. Okay, see here these 3 are in parallel, but this parallel combination with respect to this one, both are in series. In one circuit, this is parallel, and this entire combination and this one, both, sorry, these three are in parallel, this entire combination and this one in both are in series. So clear? So clear. Now, if you solve these two, then you will get only, finally you will get, it will become one resistor. Like this. Okay. So clear. The solving the circuit means here we have to redraw the circuit like this. See here one apply this one. See here we have used 4 resistors, right? So finally we made 4 into 1. We have converted or we have transferred. We can say any amount. Okay. So here we made these 4 resistors into 1 resistor. So clear, right? Suppose you know we have like this. This is R4 and R5. So now see here, these 3 are in parallel and these 2 are in parallel, but this combination and this combination both are in series. Are you getting my point? These 3 are in parallel, these 2 are in parallel. Now this with respect to this one, these 2 are in parallel and these 3 are in parallel, but this combination and this combination both are in series. See, if you solve these 3, see these 3 resistors, it will become one resistance, one resistor, right? Next, if you solve these two also it will become one, right? Correct? Now just observe it. Now both are in series. If you solve this one, finally you will get one resistance. See here, you have to make all these resistors into one resistor. Okay. I will stop here. Tomorrow we will discuss the problems. Tomorrow we will study how to make these resistors into one resistance, how to calculate the current across here, and voltage across the circuit and voltage across individual resistance. We will study everything in tomorrow. Thank you.